All right, guys, get your notebooks out. Make sure you are doing these problems as I do them as well. We learned this yesterday. If you were not sure with this concept, just pay attention. We're really going to try to do one thing. We're trying to get all our variables, our x's on one side, remember, and then our constants on the other. All right. And if I look at the variables, these are my variables here and here. Got to get those all to one side. And then my constants need to eventually get over here. All right. So let me see if I can get rid of all this real quick. And let's get that in our heads. So first step. I'm not going to play Beyonce, but if it's still in your head, I said to the left, to the left. I want you to move your variables to the left. You could totally move them to the right. It's not a big deal, but I just keep the method of just moving to the left. All right, I gave you a plan. Either way, it doesn't matter. You just got to get them on one side. Okay, now that you have your variables all over the left, this canceled out. Hopefully you realize that cancels out. Why did I subtract 2x? Because that's a positive 2x. What's the opposite of positive 2x? Remember, we're always doing opposite operation. Now, let's go ahead and subtract 4, both sides. So this is 1x. I'm just going to put x. 1x and x are the same thing, and this is going to equal negative 12. And we're good to go. Okay. All right, let's do another one. All right, take a look at this problem, giving you kind of a little bit of help to start. Your first step, it's a negative 2x. So instead of subtracting 2x, you're going to add 2x, okay? From there, let's keep going. So you guys go ahead and solve this one and give me an answer. I'm going to add 2x to both sides. All right, and then the 10 comes down. From there, I'm going to subtract 4 to both sides. I'm going to get 7x, bring on a 7x equals 6. Divide 7 to both sides and leave it as a fraction. X equals 6 over 7. Okay? Take a look at the work that happened here. I literally did each step in a different color, so you can kind of see this is a 3-step problem. Add 2x, subtract 4, move our constants to the right, and then divide the 7. All right? All right, go ahead and try this one on your own and give me an answer. This one's only a little challenging because you have to distribute the 2, distributive property. You have to multiply the 2 times the x, 2 times the 3. You did this in 6th grade, all right, multiplying distributive property, and 7th grade. Go for it. Multiply 2 times the 1, right? Isn't that a 1x? And then 2 times the 3. Write out the rest of the problem, and then it's just a simple one you've been doing already. Okay? You got this. Let's go. I'm going to go ahead and subtract 2x. Both sides get 3x plus 4 equals 6, because this got canceled out. And then subtract 4 to both sides. I get 2. 3x equals 2. Divide the 3. X equals 2 over 3, or 2/3. Okay? Let's keep it going. All right, now I'm going to intro you into a new concept. This concept is a little tricky because you have to examine the equation before you can attack it. And the only concept here that you're worried about is, well, actually, what do you notice about this equation that's a little different than what you've been handling? Okay, what do you notice? And if you're looking at this, I notice a variable here, 5x. I notice a variable here, 2x, and then 10x. So the rule with equations is we are allowed to combine like terms. Remember that idea? Combine like terms. And if you notice, these are all like terms, but you can't combine them all. You can only combine terms that are on the same side of the equal sign. This equal sign prevents, it's like a wall, like a separation bar we put. So you cannot combine all of this, but you are allowed to combine most of it if it's on the same side, okay? So let me show you. You are allowed to combine these two terms since they're on the same side of the equal sign. So to combine them just means to add them, right? So I'm going to add 5x and 2x, and I'm going to get 7x plus 3 equals 10x plus 4. Okay? And that's it. That's all you had to do there. So make sure you realize that that is important, that you take your time and get this concept in your head for next week, that whenever you notice same terms. Now, here's an idea. What if I changed it up? What if this was just a 2, not an x? Do you realize that this would have been? Do you realize that these would have been like terms? Do you see, because they're both constants? Those are both like terms as well. But I'm not changing the problem. There was an x here, okay? So we're going to combine those two terms. Let's keep it going. And then now from here, letters to the left, I'm going to move 10x over, cancel that out. All right, then I'm going to add 3. Hold on, add 3. I'm just going to put that there. I'm going to subtract 3. It gets 1. So then I have negative 3x equals 1. I'm going to put my work over here. I know it's all the same color, but deal with it. X equals negative 1/3. All right. See what I did there? I subtracted 3, got 1, then brought this down, and then divided the negative 3 here. I just did a lot of work. I wasted some space up here, so I got to keep them all together a little bit better. Okay, let's do another one like that, because this is a new concept. Okay, so if you look at this problem, there's a lot getting thrown at you here. You have to go ahead and do this part here. That's always, whenever you see parentheses, you need to clear them. You need to get rid of them right away. Remember our order of operations? Please excuse my dear Aunt Sally. Parentheses are first, so go ahead and handle that. And that shouldn't be too tough. That's going to be 8x plus 4. Okay. Now, you also have to handle your numbers on this side. All right. So I'm going to look at this. I'm going to look at this side, and I'm going to see, do I notice anything? Looking at this side, do I notice anything that I can combine? I can't combine. There's nothing over here to combine. Those are all good. Those are two different terms. That's a constant. The 4 is a constant. The 8x is your variable. All right. But over here, I have two constants on the same side of the equal sign. Same side. So I can combine those. So go ahead and combine those. 8 plus 4 is 12 plus 3x. Now, I always tell you letters to the left. Let's go ahead and subtract 8x to both sides. All right, this cancels out. I get negative 5x. Don't forget your 12 over here. And don't forget your 4 over here. All right, next step. Subtract 12 to both sides. All right, so now I have negative 5x equals negative 8. All right, so my final answer is x equals positive 8 over 5. Why is it positive? Because you have two negatives. You can leave it as an improper fraction. That's not a big deal. You can always leave them as improper. Some of you guys so desperately want to turn them into decimals and think that's better. This is how it's going to look on your big test, your state test, your high school placement test. This is how it looks. It may sometimes say select all that apply, and you may say this answer, and then you may say like 1 and like 3/5, right? Like a mixed number. All right, you may see it like that way too sometimes, or a decimal. But just know that this is the normal way. All right, let's do one more crazy one. Let me just throw everything at you. All right, take a look at this problem. It looks like a lot, but it's really not as much as you think, okay? The first step I want you handling is always handling your parentheses. So go ahead and handle these two parentheses real quick and get them set up so you can keep solving the equation. Don't handle anything else first. You always have to handle your distributive property. So do that first. And I'm going to go ahead and do that as well. So you do that with me. I'm going to get 10x, right? 5 times 2x plus 15, 5 times 3. And then write out the rest of the equation, plus 10 equals 4x. What's this going to be? Plus 2x, right? That jump right here. And then what's this one going to be? 2 times 3 is 6. Okay. Now, let's take a look at the problem. What's the next step you're going to be doing for this problem? When I look at this, there's a lot going on, okay? If I look at this side of the equation, just look at the sides. Don't look at the whole equation. Look at different sides of the equation. Is there anything I can combine? Are there constants that can come together or variables? And if you see real quick, I got 2 constants that can definitely be combined. All right, so I'm going to go ahead and do that. So I'm going to go, this is going to be, let me make that a little neater. This is going to be 25, right? And then I have 10x still on this side. Equals. What about on this side? What do you notice over here that's happening? Well, I see a variable and a variable that can come together. All right, so these two come together. That becomes 6x plus 6. All right, and now you've basically cut up the problem. And let's just talk about what we did again. We distributed property. That wasn't too difficult. We handled our parentheses first. And then we handled our like terms. We combined like terms. Okay. Now let's go ahead and finish the problem. What'd you get? Subtract 6x to both sides. I get 4x. And then I'm going to go ahead and subtract 25. I'm going to get negative 19. And then what do I get? 4x equals negative 19. I'm going to divide 4. There's my final answer. Negative 19 over 4. Again, leave it as an improper fraction. Okay? So the main part of this Edpuzzle today was that you cleaned up your equation skills and that you learned 2 new kind of ideas that you can handle. Let's count the steps in this problem. First step, distribute property. That was 1 step. Second step, combine like terms. All right? Third step, we brought this negative 6x over. Fourth step, we brought the 25 over. Fifth step, we divided the 4. So you just did a 5-step equation. All right, guys? But once you get through these first 2 steps, like this is not too difficult to look at, I hope. This is what we did yesterday. All right, guys, best of luck on this, and hopefully you guys are getting this. I'll see you guys on Tuesday.